Okay, this is the start of chapter 11. So 11.2, arithmetic and geometric sequences. A sequence is defined as just a list of numbers. Okay, so the most common list of numbers that we know about are counting numbers. So 1, 2, 3, 4, 5, 6, 7, 8, and going up and on forever. Then, of course, we have a list of, here's some even numbers. Okay, so 2, 4, 6, 8, 10, 12, 14, 16. And then odd numbers, which is 1, 3, 5, 7, 9, 11. The way this works is that these lists are actually functions, okay, in which we can actually generate a formula for each of these sequences. And I'm going to show you guys how to do that. There's one more thing that we need to define, is that these are all terms, okay? Within a sequence, you have term numbers. Okay. Now, when we talk about these sequences, we don't want to just talk about the value of the term. We want to actually talk about the term number. And we start at 0. So here, this is t0, so the 0th term. 2 here would be the first term. 3 here would be the second term. 4 would be the third term, and so on and so forth, okay? So when we're talking about term numbers, we're talking about where on the list they are, okay? So term numbers. There are two different sequences that we want to look at. There are arithmetic and geometric. There are other types of sequences, but these are the two we're most concerned with because these actually have patterns that we can follow and create formulas for. Arithmetic sequences. Their sequences have a difference generator. Let's say 1, 4, 7, 10, 13. Arithmetic sequences, they either add or subtract to get up to the next term. So this is plus 3. This is plus 3. This is plus 3. This is plus 3. And if this pattern were to continue, this would have to be plus 3. If we wanted to go backwards, we could then subtract 3, okay? But arithmetic sequences have a difference generator of subtraction or addition. Geometric sequences, what they do is their generator or their difference generator is a multiplication or a division. But a division is just a multiplication by a fraction. So really we just say it's a multiplication. So if we wanted to multiply from, or how did we get from 2 to 4? Well, we went by 2, by 2, by 2, by 2. And if this pattern were to continue for the sequence, it would be times 2 all the way. If we wanted to go backwards, okay, it would be times 1/2. Okay? So geometric sequences are multiplying as they go across. Arithmetic sequences are adding as they go across. Arithmetic is arithmetic. Okay, arithmetic. We're just putting a different emphasis on a different syllable. So instead of arithmetic, or what we call it is arithmetic, but really it's just arithmetic. Okay, so the formula for arithmetic sequences is suspiciously like linear equations. Okay, so they look suspiciously like y equals mx plus b. And I can show you why. So if we look at this sequence, we need to first decide, is it arithmetic or geometric? Well, this is going plus 5, plus 5, plus 5. So this is an arithmetic because we are adding, where the difference generator is 5. Okay. What we do also is we look at the term numbers. So this is T0, T1, T2, T3. And what we want to do is we want to build a function where if we put in a term number, we're going to get the number we want back. So the way we think of this is that our difference generator is actually like our slope. So 5 will be our m. And then our y-intercept, okay, is when x equals 0. So when is t of 0? T of 0 is 7. So our equation is t of n equals 5x plus 7. We can check this. Let's put in t t of 0. This is going to be 5 times 0 plus 7. T of 0 equals 7. Oh, good. Let's check t of 1. This is going to be 5 times 1 plus 7. This is t of 1 equals 12. And right here, our first term is 12. So we have found the correct equation for this sequence. So now we can find any term number we want. So let's say I asked for t of 100. Well, since we have an equation now, all we do is say 5 times 100 plus 7, which is going to be t of 100 is 507. So if we were to continue the sequence out until the 100th term, we'd actually find that the 100th term is 507. Okay, geometric sequences suspiciously look like exponential equations. So this is y equals a times b to the x, where b is our multiplier and a is our initial amount. Okay, if we look at this with the term numbers, t0, t1, t2, t3, t4, we have 5 terms shown, 0 through 4. And if we notice that 3 is actually our initial value, well, our initial value equals a here. So this is initial value. And this right here is our multiplier. Okay, so if we wanted to build an equation, it's actually easy as just saying y equals 3 times, let's see, what is our multiplier? How did I get from 3 to 6? I multiplied by 2. 6 to 12, I multiplied by 2. 12 to 14, I multiplied by 2. So our multiplier here is 2. So we'll say 2 to the x. However, I want to have this as a function of the sequence, so I'll change this all to t of n equals 3 times 2 to the n. Let's go ahead and check. So t to the 0th equals 3 times 2 to the 0th. Anything risen to the 0th power is just equal to 1, so t of 0 equals 3. Okay, well that checked out. Let's check t of 1. T of 1 equals 3 times 2 to the 1, which is just 3 times 2, so t of 1 equals 6, where our first term was 6 in the sequence. So everything's looking good as far as the equation. Now we can use this to start to answer questions such as what is t to the 6, which is just 3 times 2 to the 6th power. 2 to the 6 is 64. 64 times 3, 192. I just did that in my head, so let me pull out my calculator. All right, 192. All right, so this is what we're doing. We're trying to build either equations for a geometric sequence, or we're trying to build equations for a arithmetic equation. Okay, just a quick recap of everything, okay? Arithmetic sequences are suspiciously like linear equations, okay? Where d is our slope or our difference generator, okay? And then the b is our y-intercept or initial value. On the geometric sequences, everything's given to you right here in that this is our initial value. And right here is our multiplier. Okay, so if we wanted to rewrite this in terms of just term numbers, we could see it like this. This is t of n is equal to still our difference generator times n plus the 0th term. Okay, or we could see our geometric sequences as t of n is equal to t of 0 times the difference risen to an n. Okay, these are two ways to look at it. I like focusing on this because these are things I'm familiar with. I'm really familiar with the linear equations. I'm really familiar with exponential equations. By throwing in t's and stuff like that, just different types of ways of writing it, this will start to confuse me. So I really like to focus on this stuff, the stuff that I know very well.